All right, my geometry peeps. Today we are going to take a look at parallel lines, transversals, and being able to talk about the angles that are made therein. So, last time we had a video, we talked about corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles. In general, we were able to talk about which angles were which. And just being able to describe those. So if you don't remember that, go back and rewatch that video. We're just going to press on ahead and say, if I know that those two lines are already parallel, what I'm going to be able to do, okay, so parallel, you can see these two arrows here are telling me those lines are parallel. All of this only applies if the lines are parallel. So if those lines are parallel, the corresponding angles are going to be congruent. Okay, congruent, for those of you who forgot, there's our symbol for congruence. Okay, so if I look here, this angle right here and this angle right here are corresponding, and they are congruent. Okay, alternate interior angles are also congruent. Okay, we have a lot of things that are going to be congruent. Alternate interior angles are going to be congruent. All right, so these alternate interior angles would be like this one here and this one here. Those are alternate interior angles, and they are congruent. We also have alternate exterior angles. Alternate exterior angles, you guessed it, are congruent. Congruent. And so here, let's say that would be this one here, would be congruent to this one here. All right, and then finally, we have consecutive interior angles. Consecutive interior angles are not congruent. They're actually supplementary. Supplementary. And those of you who have done this before, know what's going on, know that supplementary means that they add to 180 degrees. So for example, if we were to take and say this angle and this angle, they would add to 180 degrees. All right, so those are our basic principles and ideas that we're going to be using here. And so let's solve a couple of problems. Let's do a couple of examples with this, see what this is going to look like. So here I have parallel lines. First check. Do we know that they're parallel? Yes, we do. That means everything we just said applies. Okay? So we know that the alternate interior angles are congruent. We know that the exterior angles are congruent. We know that the consecutive interior angles are supplementary, and that the corresponding angles are congruent. So because we know all of that and we look at this, I say, oh, I have this angle here. I have a nice angle right here that is alternate interior with this expression, this x plus 5. So I have 115 and x plus 5, and I want to write this as an equation. So what I'm going to do is I'm going to say, oh, I know that alternate exterior angles are congruent. And so if they're congruent, I can set their measurements equal. 115 is going to be equal to x plus 5. Then I'm just doing some basic algebra, subtract 5 from both sides, and I know that x has to be 110. Okay, that's all there is to some of these problems, okay? They're not going to be super difficult, but it is going to be really important that you remember which angles are corresponding, which ones are alternate interior, which ones are alternate exterior, and which ones are consecutive interior, and that they're going to be congruent, and supplementary. Okay, so let's keep moving on. Here we have a little bit more complexity. I have, again, parallel lines. Always check. Do we have parallel lines? Yes, we do. That means we know all of the information that I just talked about, congruence and supplementary. Now, let's look for some relationships here. So if we take a look here, and I go and I look at this angle here and this angle here, those two angles are alternate interior. And what do we know about alternate interior angles? Alternate interior angles, that's right, are congruent, which means that x equals 45. No work there. That part was done. Now, we do need to do a little bit more to figure out what y is. Okay, so if I want to figure out what y is, well, let's look at y. Okay, here's y. Well, it's on the outside. So which ones talked about outside things? Alternate exterior did, but I don't have anything over here, so that's not going to work. So I'm going to look at this one right here. That's on the inside, but it's on the same side. That was corresponding, and I know that corresponding angles are congruent, at which point I can say y equals 85. Again, no algebra to do, just apply the properties that we've just talked about. Okay, so those are pretty straightforward examples. Let's keep moving forward. Now we're going to talk about what happens if I know stuff about the angles, but I don't necessarily know that they're parallel yet. Well, we're going to be able to say, if we know certain angle pair relationships, then we know the lines are parallel. So we're basically being able to prove lines are parallel. Okay? That's the idea, is we're going to be able to go into this and say, okay, what would make these lines be parallel? So if I take here, and I have another example, find the x value that makes m parallel to n. Well, there's no labels on here, so let's label this. Let's call this m and this n. Okay? Now, what would x have to be to make m and n parallel? Well, the relationship here, this angle and this angle are corresponding. Corresponding angles are congruent if parallel. So what that means is that I need those two angles to be congruent for there to be parallel lines. So let's set that up. Go in here. 65 needs to equal 3x plus 5. Go ahead and use your algebra skills. Minus 5, minus 5. We get 60 equals 3x. Divide both sides by 3. We get x equals 20. There we go. If x is 20, then m and n would be parallel to each other. Okay, that's the idea here. All right, let's keep going. Let's take a look here. Do we know that these are parallel lines? Yes or no? So we have a picture, we have some angles, and the question is can we say that these are going to be parallel or not? Now, this angle here is 75 degrees. It forms a straight angle, a linear pair with this angle right there. So I know that the two angles together need to equal 180. So if I take 180 minus 75, I'm going to get this unknown measurement, which is going to be 105. Okay? So this is 105, this is 110, and the question is does this mean that I know this is parallel? In this case, no, it is not. It is not parallel because corresponding angles are congruent, or in this case, are not congruent, so the lines are not parallel. Okay, so the parallel, for these two lines to be parallel, the corresponding angles would have to be congruent. All right, here we go. Another example, very similar. In this case, let's see what we got. Is PQ, so we're talking P and Q here. So are those two lines parallel to each other? And so we're going to look at this and go, all right, well, what do I know? Do I know? So vertical angles would tell me that this angle here and this angle here would match. Vertical angles would tell me this angle and this angle would match. But I don't know anything else. I have no other information. So taking a look here, I'm not going to be able to, so no, there is not enough info. we would need two angles, on one transversal. So what that means is that here I need to know something about these angles, or here I need to know something about these angles. Because I don't know anything about those angles, I can't say anything about it. So in reality, we can't even say no. We would have to say, maybe? Question mark? All right, does that make sense, guys? If not, leave a comment, ask me in class, do whatever we need to do. All right. Last piece of this, the transitive property. Transitive property says, if two lines are parallel to the same line, then they are going to be parallel to each other. Okay? That is the transitive property. And so what we can say here is if L is parallel to M, okay? L is parallel to M, and N is parallel to M, okay? So let's put purple on here. Then what we can say is that L is parallel to N, meaning that this first one would be parallel to this last one. So all three lines are parallel to each other because each line was parallel to the same line. L was parallel to M, N was parallel to M, and so we can cut out that middle piece where we both were parallel to M and say that L and N are parallel to each other. Okay? So there's our brief conversation of parallel lines and their angles. We'll do lots of practice. We'll do more with this, but that just gives us a good idea to get started with.